Hackers are able to disrupt a lot of things, and that also includes industrial things. There were several cases where hackers were able to disrupt oil and gas plants, energy grids, water plants, and so much more. So, how does this happen, and how can we prevent it from happening? So it's important to understand what ICS and OT is. So ICS, or Industry Control System, basically incorporates several devices, systems, networks, and controls used to automate these industrial processes. Think of it as a steel manufacturing plant. Now, OT, or operational technology, this is the hardware and software that is going to be used to interact with the physical world. Now, think of this as the robot arm bending steel in these steel manufacturing plants. So now OT has become more evolved over time. We're using sensors, and these sensors are often Internet of Things devices, meaning they interact with the internet and just to send data, receive commands, control machines remotely, and etc. And so once these sensors are online, they become a potential entry point for attackers. Now, there could be a vulnerability in a sensor that an attacker could get into, and then once the attacker gets into the sensor, they can start, messing with the network, the physical equipment, causing damage to the physical equipment itself, and causing financial loss. And so there may be certain anomalous readings that may indicate a potential hack, and it's important that we detect them. And so to detect them, I've created an app that uses the isolation forest machine learning model. And what it does is that it basically picks out the outliers or the weird readings. And it does it by splitting the data and isolating the points that behave differently from the rest of the other data points. So in this app, the model is first going to be trained on one part of the data to learn what normal looks like. And then it's going to use the other part of the data to actually score and rate how anomalous and weird those readings are. Okay, so this is our app, and before we can start using this app, it's important we have a CSV file. In this case, we have the timestamp and then the sensor readings, which is pressure, temperature, flow in this case, and we've recorded the sensor readings for each minute. So we're going to first load the CSV file we just talked about, and it's going to load the rows, and we can see that the isolation forest machine learning model has been selected, and this is our graph. And so first, these orange points are going to be the anomalous readings that we have counted as alert. This dotted line represents the threshold value. And if we scroll over here, it's set to 0.99. So that means only the top 1% of the anomalous readings are going to be counted as alerts and as anomalous readings that we have to worry about. And the rest of the other 99% of the readings are going to be considered normal. And so the line that draws between it being considered as an alert and it being normal is this line, and the value that is selected over here is 0.627. that is done through our slide bar over here. And so if we scroll down, as you can see, we have a total of 12 anomalous readings that we have counted as alerts. And over here we have the rule back section where 3 of those alerts have met the physical rule we have kept in place, which is over here. And so what this means is that within the current minute, if the change within the current minute and the previous minute has exceeded or decreased by 50%, we can say that it has met that physical rule, and it'll have a check mark here in place. So let's go over the columns once again. So the time is the timestamp of the alert, the anomaly score that our machine learning model has been able to do, the most abnormal feature at that time, the physical rule if it has been met or not, the top 3 most abnormal features at that time, and then the top 3 z-scores. Now, z-scores are readings that we have calculated so that all readings from different sensors with different units and measurements, like temperature having different measurements than pressure, we have calculated in a way so that all these readings are uniform and can be comparable to one another. And so now let's move on to downloading all this. So download scores.csv is going to be able to give us the anomalous readings that our machine learning model has been able to score. As you can see, it has all these timestamps and then different scores it has able to score. And we can have alerts.csv, which is going to contain the top 1% of anomalous readings that we have counted as alerts and something that we have to worry about. And so for all this to make sense in plain English, we can download incidents.md report, which is going to have all these different scores, readings, and features in plain English, so that it has created a report where you can show this to a security analyst or an engineer that can easily understand on what's happening and may know what the next steps are.